All right, I have two different ways that I could think about graphing this. I could start with my long division, or I can look at this and know that my numerator factors. So g of x is x minus 3 times x plus 3 divided by x plus 3. Well, notice that those x plus 3's are going to cancel. But in the original function, I know that x cannot be equal to negative 3. This is not in my domain. So g of x is going to look like the line y equals x minus 3. So y equals x minus 3, well, that has a y-intercept of negative 3 and has a slope of 1. So I'm going to go through here. But when x equals negative 3, I would come down here at negative 6, but I know x can't be negative 3. So that makes a hole in my graph. This is what we call a point discontinuity. So otherwise, I look like this line. My line would continue this direction. Except for here, I have a point discontinuity. So we have point discontinuity at negative 3, negative 6. This line, of course, would go through the point negative 3, negative 6, but I can't because that means in my original I would have divided by 0. So this time it's not an asymptote, it's a hole. Let's think about what would have happened if we had done our long division. I would have had x plus 3, and actually, not even long division, let's do synthetic division. So negative 3, 1, 0, negative 9, negative 3, positive 9, remainder of 0. So I know through my synthetic division that this looks like x minus 3 plus 0 over x plus 3. Right? This is a factor. This remainder of 0 tells me that it only looks like x minus 3, but I have to know that I had a division by x plus 3, which means that x equals negative 3 does not exist in this line. All right, so clearly my 0, negative 3, and 3, 0, my intercepts are labeled, no asymptotes, and that's this graph.